A dream come true. This was Elon's first expression when SpaceX stacked a Starship prototype rocket on top of a super heavy rocket booster for the first time. SpaceX started to develop this rocket in 2016 as a self-funded private spaceflight project. 4 years after work began on the Raptor rocket engine that powers both stages. After achieving SpaceX's first milestone to land Falcon 9 and Falcon Heavy successfully, Elon realized that in order to make humans multi-planet species, he needs more advanced technology that could be fully reusable. In Falcon rockets, the second stage and Dragon's unpressurized trunk are not reusable. Even the reusable parts are not rapidly reusable. It takes a fair bit of effort to bring them back for another mission. In order to do this, they literally enhanced a lot of theories and methods in rocket science. They developed a new methane-powered engine to increase the performance and make the flight cost cheaper. They used stainless steel in the rocket body instead of aluminum or titanium like most rockets. Literally, they changed many common things that we've always known in rocket science, just to meet the number one criteria of making this rocket fully reusable. In other words, they wanted it to look like a commercial airplane, with short turnaround times between flights, such that the only major cost is fuel. These goals sent SpaceX engineers into a new world of complex problems. They made a lot of prototypes and tested them, sometimes with spectacular results, but a few early models have exploded. After each test, they take the data and analyze it to see what could be changed to make it perform better. One of the latest changes, according to Elon Musk's latest tweet, that 2 of the 4 flaps that largely make the exotic maneuver possible are set for a small but significant redesign. Today, we will take a deep look into this and see how this issue could affect Starship and how SpaceX could fix this issue. So if you are new here, it will be greatly appreciated if you liked and subscribed to our channel. It's free and you will receive a lot of value. Before describing the error, we need to understand the fins function and its story in the Starship. Fins are air brakes used to control a rocket vector in the air. You can use a lot of aerodynamics conventions. Most rockets use a servo-actuated one-axis gimbal assembly to rotate control fins by tiny margins to achieve one or all of these goals. Roll control, correct off-vertical ascent or re-entry. Starship started with 2 front fins and 3 rear fins. The 3 rear fins were used as legs, as well as its main function in rocket stability. So the front fins actually act like canards, that part of an airplane that functions as a stabilizer or elevator and is installed in front of the main wing. In Starship, they produce 2 axes of control through the x-axis of the rocket, and they are essentially passive during the final tail-down landing portion. But why did SpaceX remove the 3rd rear fin, you might ask? Besides the fact that fewer fins means less weight in the first place, when re-entering, Starship will be belly flopping in this process with 3 legs attached at 120 degrees apart of each other. 2 fins will articulate to be so close to the center of mass of the rocket, which consumes a lot of energy in moving them throughout the re-entry process. So the short answer is the 3rd fin on the back was really completely passive and out of the wind stream, while with 2 fins, when partially retracted through the re-entry, would have a better, more passively stable configuration. Furthermore, SpaceX plans to catch a Starship, which means there will be no need for legs at all. Now let's see how a Starship uses its 4 fins. In order to achieve specific movement, the 4 fins work in harmony with each other. So to induce pitch, the top and bottom fins move opposite each other, which can help pitch the nose up or push it down. To induce roll, the left and right flaps can move opposite each other, extend one side more than the other, and the vehicle will roll. And to induce yaw, for this we move opposite corners of each other. Top left and bottom right can move opposite of the top right and bottom left. This is very important while it belly flops through the atmosphere. SpaceX is getting ready for its Starship first orbital flight, After many testing and simulations, it seems like this is the best design at this moment to move pretty fast and test the concept. More testing means more data. Lately, Elon Musk tweeted that there is a slight error with the current design of Starship's forward flaps, necessitating a few small but visible changes on future prototypes of the spacecraft. During the actual process of re-entry, in which Starship uses a heat shield made up of 15,000 ceramic tiles to slow from orbital to subsonic speeds about 7.5 kilometers per second, those same flaps also come in useful to control the vehicle's angle of attack, and thus the degree of extreme heating experienced. According to Musk, to improve the moment arm, or torque in other words, of the Starship's forward flaps and reduce or remove undesirable aerodynamic characteristics, SpaceX is going to shrink those forward flaps further, move them closer together and more towards the tip of Starship's nose, and angle them toward the ship's leeward side, the backside. Ultimately, those relatively minor changes mean that a portion of Starship's forward flaps will no longer be directly subjected to re-entry heating, conceivably allowing SpaceX to entirely remove static aero covers that wrap around the ship's flaps to prevent superheated plasma and gas from reaching sensitive components. SpaceX's thermal protection team completed the installation of heat shield tiles on one of those forward flap aero covers for the first time ever just a few days ago, a structure and portion of the heat shield that will apparently no longer be needed on future Starships. One important piece of making Starship fully reusable is improving its durability to survive the intense process of re-entering the Earth's atmosphere. As Elon once described, space is easy, orbit is hard. What do you think? What else can be improved in order to achieve the best flight experience? Let's discuss it down below. Thanks for watching.